All right, so we are here to talk a little bit about Kubernetes and generative AI, right? But there are tons of things happening in that space. Over the last 5 years, we have seen tons of different companies building amazing and scalable platforms on top of Kubernetes, choosing from the Kubernetes from the CNCF landscape. Tools like Linkerd, Istio, Cilium, Envoy to create amazing network connections between our applications, using and bringing mature GitOps approach with Argo CD and Flags. Being able to scale applications using tools like Keda, Knative, just in a smart way, right? For very complex scenarios. And using tools like Crossplane and Dapr to provision a lot of infrastructure on different cloud providers, and then enabling developers to access all this infrastructure via APIs. But we cannot forget about the underlying observability space that OpenTelemetry is pushing to make sure that no matter which tools we are using, we always can understand what's going on in our workloads and infrastructure. For this presentation, though, we cannot talk about all these tools and all the things that are happening in the platform engineering space. So with Alexa here, we have chosen 3 different pillars that we consider that are extremely important for companies building platforms. The first one is X as a service. How do you expose a simple service for consumers while you're using all these complex tools from the ecosystem? How do you enable developer experience when, again, you have all these complex tools, but developers are already used to build applications in their own way? So we need to enable them in a smart way, so they can just build more complex applications. And finally, as I mentioned before, observability is always there, but there are a lot of new challenges coming up on that space as well, so we'll be talking about that.
Our platforms have clearly evolved through time. So today, we're going to talk about the transformation from traditional to GenAI. Now, it's important to note that we never just discard old elements. Instead, we transform or use them. And just like any great recipe, through time, there are things that never need to change. They're great as is. Some things we need to substitute. They may be similar, but we need to update them to meet new needs. Also, there's some things we need more of or less of. With GenAI, we've been able to create something new. But we've added complexity, yet we've added complexity, but it's still very powerful. So let's walk through the evolution of how our applications and infrastructure have all transformed to meet the needs of this new GenAI era.
Let's do it. So if you are thinking about platforms for very traditional applications, we kind of know how it works. When you look into applications, you need to kind of understand how your applications behave, how do they scale, how do they manage and exchange data across different microservices. And for that, we kind of know if you are in this space, right? If you are right here at KubeCon, you are surrounded by experts that understand how to, for example, scale up web applications or REST endpoints. If you're using Kubernetes, you know that if you have more requests for your application, you will just create new replicas of your application, and that's pretty well understood nowadays. Again, if you are starting, you are surrounded by experts, so you are in the right place. And again, applications will exchange data. We can understand how that works, probably JSON payloads or gRPC. And then when we want to store data, we have traditional databases that we have mastered into Kubernetes, how to run them in Kubernetes, and how to fine-tune them in Kubernetes. So let's add all that to our big pot, and let's start thinking about, okay, what's changing now that we have predictive and generative AI?
So predictive adds complexity, and let's see how. We still need APIs, so we created specialized serving runtimes that wrap around our ML models and allow us to access them. Since we need to download our ML models, this increases our scale. Additionally, we still have defined input-output, but the shape has changed a little. Now we have a standard tensor protocol. We still need to access data, but now this is specialized to store our features. So let's add in our potion to add some complexity from predictive. What we get is something a little different, a little more interesting. Now it bubbles a little. Now let's talk about how GenAI adds even more complexity to that. So now we have large language models, which are exactly as they sound, quite large, and increases our scale and complexity quite a bit. Additionally, we need to connect to different types of services, so agents and tools, and we need to support that. This is probably the biggest change and the biggest difference from the last 2 platforms. So our outputs are variable. Given a prompt, you might have a different size output, and the size is measured by tokens, and these tokens are streams, so we have different patterns that we need to consider. Which means also we have different ways we need to observe and manage our services. So for example, latency needs to be measured by the time it takes to get the first token, and the inter-token latency after that. Again, we still need data, but now vector databases, so we need to be context aware for interactive workloads. We put all this complexity together, and we have, again, something new challenges, but also new solutions. So generally, a GenAI architecture can be a bit complex because we need to access various LLM providers, cloud, and also maybe some self-hosted ones. All of these might have different ways that they handle auth and different APIs. So for the end user, this can become quite complex. But platform teams, what we want to do is take away that complexity. So what we can do is add an AI gateway to help us configure all the security and routing for you, and also provide unified control plane and protocols like MCP to allow all these components to connect seamlessly. Again, we want to support our vector databases and be able to retrieve our context, so we can also make RAG systems.
It's getting complex, is it? Right? But let's talk a little bit about infrastructure, right? Because again, if you're building traditional platforms for running traditional workloads, we have mastered how to do that on top of Kubernetes. So we need to look into a little bit more about like the kind of things that we have on the infrastructure side in order to understand what's changing when we are dealing with predictive and GenAI. So we already know, we are here at KubeCon, so Kubernetes is kind of like the basic of the things that we are building. We will have our microservice containers, how do you build containers and all that stuff in there. On the hardware side, again, traditional applications are much easier to analyze and understand how much CPU they will need or how much throughput they will need to support, right? And again, like databases and fine-tuning that, it's something that we are already used to. So let's add that into a pod, and then let's see how that changes for predictive AI, right?
So let's add more complexity again. We still need our services, but they're specialized for predictive inference. So we have transformers for pre and post processing and predictors for this. Also, now we have specialized training pipelines. Additionally, we have some different hardware requirements. Now, some models will rely on GPU, and we need to support that. As well, we still need to we still have some memory bottlenecks, and we still need to cache some things. Now it just looks like embeddings and features. Again, we added this complexity, we get something different. But GenAI breaks traditional infrastructure, and let's talk a bit about why. So now we have different frameworks we support. Instead of our training pipelines, we have fine-tuning. And importantly, we rely way more heavily on GPU usage. This is resource limited, and also, I will say, it's not the cheapest ingredient to add a lot of. So we need to optimize and make sure we utilize our GPUs. Also, we have different ways to measure our throughput by LLM capacity, like things like token or KV cache. These are the things that matter and affect how we need to understand our services. Again, we have other memory considerations and bottlenecks. These large models take a long time to download, and also we have to process every single prompt we get. Oh. I think that's all right. Oops. Okay, so let's add all this in together. Now, again, new challenges, new solutions. So if a pod takes a long time to start, what we need is model cache. Also, for every prompt, we want a quick response, which means we need to tune our latency paths. Also, if a model can't fit on a single node, then we need to have distributed inference in order to serve that model. So KServe is a CNCF open source tool that's made to operationalize our GenAI deployments. And I'm very impressed by the community and all the work they've put in to create this GenAI inference API to help solve all of these challenges and to help us lower the cost of inference. So if you want to learn more, there's a link there. But this is just one tool you can use.
Exactly,
Mauricio, can you tell us a bit about why, and remind us why all of this is important?
Let's go back to the 3 pillars that we mentioned at the beginning, right? So when you think about X as a service, when I look at it from like a development team perspective, what kind of like services do I want to provide? Maybe I want to give them a database as a service, or maybe I want to give them a development environment as a service, or maybe even further, I want to give them, like this entire test application ready for them to test. So when I think about that, I think about, again, as I mentioned before, tools like Crossplane and Dapr combined together in a way that they can just provision like an entire environment and then make it accessible for developers. When you do that kind of stuff, you have an end-to-end story for developers just to start doing their work instead of thinking, how do I consume all these complex tools? And something similar happens for data scientists.
Yeah, exactly. We shifted from a platform that now we're building self-service systems that optimize every request. So using open source tools like KServe for self-hosted LLMs, if you add with it the Envoy AI Gateway, for example, which gives you observability and intelligent routing for GenAI for self-hosted and cloud providers, now you've created something that can use LLM as a service, as a platform. Add a couple more components like the batch API or a queue, and now all of a sudden you can also offer batch inference platform as a service as well. So this is a shift that I want to note from a platform team building for deployments or ease of deployments to actually solving access patterns. And this is importantly made possible by building upon and standing on the shoulders of open source projects that were originally designed for traditional and predictive platforms, which really highlights the power of open source and open innovation.
And on that note, I've been looking kind of like the space over the last 6 months, which has been crazy. A lot of agentic frameworks are popping up in the industry, and that's great. But when I think about developer experience and giving frameworks to developers, I think that for me, that on top of my mind, it's really important to say, I don't want to give you a framework that I haven't tested in production before, right? And that's why I'm extremely excited about the Dapr Agents project. You can take a look at the CNCF blog post that was announced in March, which basically builds an agentic programming model on top of, for your application developers to use, on top of a CNCF graduated project. So check it out if you haven't seen that, and let's talk a little bit about observability as well.
Yeah, so GenAI demands new observability. We need to track our tokens. We need a token level latency and throughput view. Also, we need tracing through our prompts and through our agents to understand how we got the answer we got. These are no longer nice to haves. These are something that you really need for having an LLM that's enterprise and production ready. And you need to bake these into your SLOs, which need to be actionable. So, what's the takeaway from all this? Well, the power is in how we mix our ingredients and our elements together, not on the elements themselves alone. And with this, our platform should all be an ecosystem of models, tools, data, and agents. And it's very important that we can interchange these and make them composable. How do we do that? Through open protocol and focusing on our open source solutions. So this is the elixir that can turn our raw infrastructure into our golden GenAI platform.
So no matter what kind of platform you are building today, always think about composability and interoperability. If you are looking into new GenAI tools, think about how these tools are going to interoperate with the things that you already have in the platform. Because if you combine composability and interoperability, you're actually creating the catalyst for innovation and unlocking speed for your platform teams. So with that, thank you so much for being here. Have a wonderful KubeCon, and arigatou gozaimasu.
Thank you.